All right, so this lesson is on 7.1, 7.2, which just starts angle relationships, okay, with chapter 7. So with your page here, we're just going to start by classifying triangles and make sure we understand triangles. This is something you should know. I think most of you do. But let's just go through each of these and make sure you're sound with triangles here. When you talk about a scalene triangle, here's what's going on. No sides or angles are equal in this triangle, okay? When you move to an isosceles triangle, all of a sudden you see the two markings here, okay? You know that they have two equal sides and two equal angles. And more in particular, the two angles that are the same are not the angle that touches the two equal sides, it's the other two, this one and this one. And then the very last one, the equilateral triangle, we know that all three sides are the same and all three angles are the same, and the angles are actually always equal to 60 degrees. It's 180 divided by 3. So scalene to isosceles to equilateral. No sides or angles, two sides and angles, three sides and angles. Okay? Now, an acute triangle has one thing in particular. All the angles are less than 90 degrees. Less than 90, less than 90, and less than 90. But as soon as you make one of your angles, and it looks like it's close right here, a 90 degree, we call it a right angle. We did a lot of work on this one with the Pythagorean theorem. Okay, Pythagorean theorem has to have a right angle. But when you have an obtuse triangle, do you see this angle right here is bigger than 90 degrees? You're only able to have one of those angles, but one angle is above 90 degrees. Okay? So 6 different triangles, just so when you hear isosceles triangle or right triangle or obtuse, you know what we're talking about. Now, polygons. A polygon is a closed figure. It means it starts and ends at the same point. Starts, ends at the same point. So they're closed figures where all line segments, all the sides are straight lines. Now, this is key. There's going to be a lot of questions going forward that if you don't see regular polygon, you're not going to know what to do. This is a regular polygon. All the sides are the same. This is a regular polygon. Notice all the sides are the same. This is not a regular polygon. Do you see how these two are the same, but it's not the same as these two? This is not a regular polygon. This is not a regular polygon. These two are regular because all the sides are the same. And then you've got the names. You've got triangle, quadrilateral, pentagon, hexagon, all depending on the number of sides here. Okay? Let's get down to what's new on your page. What is a polygon? Well, a polygon is simply a two-dimensional closed figure whose side lengths are line segments. Okay, so I'll get you to write that in. Two-dimensional means it's flat. Closed means it starts and ends at the exact same spot. This would be an example of not a closed figure. You see how that looks like a U? It doesn't close. It doesn't end at the same spot. We would have to close it right there. And this is not a polygon. Straight line, and then we have a curved line to go to there. That's not a polygon. Okay. Next, what's a vertex? A vertex is a point where two sides of a polygon meet. Just look up here real quick. This is a vertex right there. This is a vertex. This is a vertex. Wherever two sides meet. 1, 2, 3, 4. We call those vertices. 4 of them. Okay? An interior angle is an angle formed on the inside of a polygon by two sides meeting. Okay? So just draw your attention up here. Let's just take a look at this parallelogram. Okay? This would be an interior angle. I'll use a highlighter here. This is an interior angle right here. That's an interior angle. This is an interior angle. Same with this one, and then same with this one. These are all interior angles in here. But as soon as you take a side, for example, this side right here, and we extend it. See how I extended it past the vertex? What we've done is we've created this exterior angle right here. As soon as I take this figure and I take this side and I just extend it, one side's 180, never that side, but do you see this exterior angle right here? If I extend this side right here, exterior angle right here. These are all exterior, they're on their outside. So an angle that's formed on the inside of a polygon versus an angle that is on the outside of a polygon. Is everybody okay with interior versus exterior? You know what's really neat here? I love making connections in math. Interior, exterior, you remember interpolation, extrapolation? Interpolation was inside, extrapolation was outside. So it's the same kind of prefix there, in, x. All right, last thing. Equal angular means having all angles the same. We'll get to that in a couple questions here. All angles are the same. All right, everybody good with that? Now, once you're done, we'll move to the next page here. Now, here's what we're going to do. We are going to get into the art of finding measurements of angles. Finding what that angle is. Is it 53 degrees or is it 92 degrees? What is the measurement of that angle? And in order to do that, we need some tools. We need some theorems to help us. So what I'm going to do is, I always like to use the analogy, I'm going to give you a tool belt. Okay, you all just got a tool belt. And now what's going to happen is I'm going to give you a bunch of tools for this tool belt. The very first tool that I'm going to give you is something called supplementary angle theorem. And supplementary angle theorem can be summarized as this. Angles in a straight line add up to 180 degrees. Angles in a straight line add up to 180 degrees. So, to be a little more specific, if we take a look at this, do you see this straight line going across here? From here up and over to the other side. This is 180 degrees. So when I look and I say, I need to find this angle x because that's where my variable is, I need to know, is this 92 degrees or is this 60 degrees or is this 5 degrees? Well, what I'm going to do is I'm going to use the fact that the other side is 85. So if you know the whole angle from here all the way to the other side is 180, and I'm telling you this portion of it is 85, how would we figure out the other angle?
Subtract 85 from 180.
Absolutely, we would just subtract 85 from 180. And what we end up with is 95. Okay, 95. Now, what you're going to do, though, is you are going to add your theorem. Your theorem is supplementary angle theorem, SAT. So SAT goes on the end here, and that's the reason you can say it's 95 degrees. 180 subtract 85 is 95. Okay? Does that make sense? No questions? All right. Second one is complementary angles. Okay? Now, complementary angles are those angles that say please, they say thank you, they hold the door open for somebody. Those complementary angles are just... Jackson got it, nobody else. Owen's smiling a little bit. Complementary, okay? Complementary angles are not angles that say please and thank you and so on. What it is angles that add up to 90 degrees, not 180. It's almost half of a supplementary. What's that? Angles. So, how do we figure out angle M? M is this angle here, going down and then up this side over here. How do we figure out what this angle is right here? Well, we couldn't unless we knew this angle right here. Because we have a little box in this corner, this 90 degrees, I know I can figure out M by saying, well, M is the complementary angle to 30. It's 90 take away 30, which is 60 degrees. What do you think we're going to put at the end of 60, though? What is it? CAT for cat. Complementary angle theorem. CAT. Just make sure you guys know you're being recorded right now. All good there? So if you're given a 90-degree angle, you know one angle, you can figure out the other. Okay? Let's go down to opposite angle theorem. Opposite angles are equal. Plain and simple. So, if you were to take a straight line, and watch here, this is a nice kind of visual. If you were to take a straight line and cross another straight line, do you see how you create these four angles? When you cross two straight lines, you always create four angles. Now, you see this angle R right here that we're trying to find? What I did ahead of time was I made a separate angle. Do you see that? So I just took that angle away. Now watch what I can do. I'm going to take this angle that I took away, which is R, and I'm going to spin it 180. And when I bring it over here, do you see how it fits perfectly into the other side? Opposite angles are equal. So I know if this side is 70, guess what the opposite side is when two straight lines cross? It's also 70. There's no calculation here. We don't have to subtract it from something. We just say R is equal to 70 because of opposite angle theorem. OAT. Now, here's where we're headed, okay? This is a little bit of an extension, so I'm not going to mess up your diagram here, but here's where we're headed. If I wanted you to figure out this angle and this angle, we could take this straight line. Do you see from here all the way over to here? How many degrees are there? 180. Remember SAT? This straight line right here has 180 degrees. So if this is 70, this side over here is 110 because of SAT. And then we can do another opposite angle, and we know that this is 110. 110 plus 70 plus 110 plus 70 is actually 360, which is a circle. Isn't that cool? Okay. Over here, angle sum of a triangle theorem. Really, really math techie term for just saying the three angles in a triangle always add up to 180 degrees. Now, before we do anything, watch this. This is one of my favorites. Watch this. Do you see this angle Q right here? I'm going to bring that angle over here. Do you see this angle 50? I'm going to bring it over to here. See this angle 55? I'm going to bring it over to here. If I start with my 55, I take my angle Q and I spin it around. I haven't changed the magnitude, I just changed the direction. Notice how it fits perfectly right here. See that? And then if I take my last one, which is the 50, take a look, I can butt it right up to here. And what did I create? A sat. Do you see the straight line going across? How many degrees are from here all the way over to here? 180. So this plus this all equal 180. Isn't that cool? All right, so here's the theorem. Oh, let me backtrack there. In SAT, the angles add up to 180 degrees. Or sorry, in angle sum of a triangle theorem, they add up to 180 degrees, which is technically a SAT. So what would we do to figure out angle Q? Owen?
Subtract 180 from 105.
Just be careful. Say it the other way around. Subtract 105 from 180. Okay? So we're going to take those two angles away from 180, and I end up with 75 degrees. Angle sum of a triangle theorem. ASTT. Angle sum of a triangle theorem. Everybody good? Mike? Absolutely. Everybody's good there? All right. Isosceles triangle theorem. Take a look here. This is an isosceles triangle because of these two right here. What I know is this side and this side are the same, and this angle and this angle are the same. In an isosceles triangle, the two angles not between the equal sides are equal. Length or measurement, I guess. I'm going to get rid of this equal length because it makes it sound like it's a side length. The two angles not between the equal sides, not this one, those are equal. So we can very straightforward just say 75 ITT. I'm giving you all these tools that you're going to be able to use on a problem. You're going to have to pick out which tool to use, though. Okay? ITT, isosceles triangle theorem. Any problems there? Equilateral triangle. Well, if a triangle has 180 degrees, and in an equilateral triangle, every angle is the same, we just go 180 divided by 3, 60 degrees, ETT. All angles are 60 degrees. All good there? Now, here's one that always seems to occur in a problem, and it's one you've got to visualize, okay? So, let me just set this up, okay, and we'll go from there. There is a relationship when you take a triangle and extend one of the sides. Do you see how we took this side and extended it? There's a relationship between this extended angle, this exterior angle, and not the angle right next to it in the triangle, but the other two. There's a relationship, and let me show you what that is. I'm going to start by creating this angle right here. Do you see the 60? I can go up this way, and I can go down this way, and I've created that angle. I'm going to group those two together. So you and you are now a group. And since they're a group, I can move them together. Do you see how that angle right there is 60? I'm going to do the same thing. Maybe I'll grab the green this time, and I will go here. So my 45 is this, and this right here. And I will group these together. So you and you are now, whoop, get back here, are now a group. And do you see how I've got this angle right here? There's a relationship between B and these two angles. So watch what I'm going to do. I'm going to take this 45 and I'm going to bring it over towards B. I'm going to plop it right down here. Okay? Then I'm going to take this other angle, which is 60, and I'm going to spin it around. And what should happen is this should very nicely fit right in this space where the green ended and where I need to end with B. Do you see that? This angle B is actually the 60 plus the 45, not the one next to it. This is called EAT, or EAT, exterior angle theorem. And what the theorem says is that the exterior angle is the sum of the opposite interior angles. Okay, you guys understand the exterior angle? So, just very quickly, you see how this is 60? You see how this is 45? When I add these together, I get 105. So, that is the measurement of angle B. Now, what I could have done is I could have picked a different side. So just watch here quickly. I could figure out using ASTT, I could figure out what this angle is right here, right? And if I were to extend this side here, this angle here is just whatever I figured out here plus this. I could extend this side right over here. And this angle here is this plus this. Whenever you extend a side, this one here is just this plus this, and that makes sense because these are opposite angles. We've got a whole spider web of angles working together here, okay? Is everybody okay with EAT, E-A-T? The next three all deal with, you see, parallel lines, and parallel lines? We all deal with parallel lines, and we know these are parallel lines because of the arrows. We know that those two are parallel, parallel, and parallel. And here's the first one. This is called corresponding angles. And corresponding angles form an F pattern. Now, there you go, Jill. Now, let's just take a look at this here, okay? The way that I always dealt with parallel lines was I would say, okay, what angle am I given? And do you see how this is the angle I'm given from here to there? I know that that's 68. And what angle am I asked to find? I'm asked to find M from here to there. Do you see how I drew my two angles they gave me in the diagram? How do I connect these two? I connect them by just extending this line over to M. And do you see what letter is upside down and turned around? Do you see the F? There's actually an F there. If I were to take this, get back here. If I were to grab this here and group it together, then what I have is this F pattern. Don't you dare laugh at my F. Do you see the F though? So if I undo it, undo, undo, and undo, there it is, okay? So what I now know is M is equal to 68 degrees because of the F pattern. Another way is, do you remember this? Remember going down with the red here and across here? And I know that that's 68 because it's labeled in the diagram. I'll group these together. And if I take this 68, do you see how I can bring this 68 down here and it's exactly what M is? See how it fits in there? Now, the one thing to keep in mind is in a set of parallel lines, there are a bunch of F patterns. So here's the first one, and just watch. The first one is down, over, and over. These two angles are the same. But there's another F pattern in here. Even though the angles aren't labeled, another set of angles that's equal with an F pattern is down, this way, and this way. These two angles are the same. Okay? Then we can flip them, and instead of going down and over, we can start with this line, and we can go up and over and over. And the inside two angles are the same. And the last one, the fourth one, is we can go up, over, and over, and these are the same. These are all F patterns. There's 4 of them. Does that make sense to you guys? Okay, we'll get a little practice on this later. Let's go to the second parallel line property, and it is this one right here. It's called alternate angles. Now take a look here. If I were to go like this, once again, and if I were to draw this line here and this line down, okay? Group these. I now have this angle, which is 83, and I'm just going to clone this thing. I'm going to make a duplicate, okay? I'm going to bring it over to the W, and I'm going to flip it around. Watch what happens here. This fits right into the W right there. Do you see that? But what letter did you just form? A Z. Do you see the Z or the Z right here? So this is angles forming a Z or Z pattern. They are equal. The only other Z pattern we have here is this. This and down. This and up. Do you see the green Z pattern here? It's like a backwards one. This angle and this angle are the same. So what we can say here is there's 2 Z patterns in every set of parallel lines. Those 2 are equal. All good? There are 4 F patterns. There are 2 Z patterns with every set of parallel lines. And we've got one more. We've got one more parallel line. Is everybody okay with that? Last one, co-interior. Interior means inside, co means more than one. So if you take a look, do you see how we have the X on the 72? But this isn't an F pattern. We don't have one on the outside. This 68 is now on the inside. You see here in the 72? When I were to make these 2 angles, go from here over for X, and here down for the X, there's the X right there. And if I were to group these together, and I were to grab the red right here and straight up for the 72. Okay, is everybody okay with the 2 angles? And I group them together. When I take a look and I look at these 2 angles, here's my green, my X, and here's my 72. And what I do is I try to get them onto the same plane, the same line. They probably are going to be equal, and I put them together and oh, wait a second. Those aren't equal, are they? They're not equal. But watch. If I were to take this and spin it around, and if I were to take this and butt it right up next to the other one, what did I just form? Stat, a straight line. These two add together to give you 180. These parallel lines are the same. These angles are the same. The second one, the angles are the same. But don't get confused. The third one, these are not the same. The interior angles don't equal each other. They actually add up to 180 degrees. So we take 180 and we subtract 72 from it, and what we get is 108 degrees, and it's called the C pattern. Okay. Any problems with those tools that we just went through? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tools. Your tool belt must be getting heavy there. You've got 10 tools that you can use to solve for angles. Now, on any given question, when you've got the one angle, it's not too bad. But what we're going to be doing is we're going to be solving questions like this. And you don't have this in your book, but let's go through this together here and then we'll stop. Okay? What if I gave you a question like this? I'm just going to shrink this down a little bit. I'm just going to shrink this down a little bit so it's completely in my screen here. You don't have this, okay? You don't have this, but let's just go through it together. We want to find, and I'll put this down here, I'll put this up here, and I'll bring this to the front. There, perfect. Let's go through together and find what the measurement of A, B, C, D, and E all are and what our reason is. We'll go through this together. So when I look at this right now, there are 5 angles to solve for, but here's the thing. I cannot solve for all 5 right now. There is only, I think, one angle that I can find right now. And before I get to any of the other angles, I've got to like unlock this angle. It's almost like a video game. You unlock a new board or a new something for your game, I guess. What angle would you unlock first? Which one can you find first in this diagram? Is it A, B, C, D, or E? Which one first? There's cats, there's sats, there's oats, there's ETT, there's Jill sleeping. There's all kinds of stuff going on right now. Which one is the one that we can unlock first here? Liam?
E.
It is. Why can we do E right now, Liam? What is E and why?
ITT.
It's an isosceles triangle. Do you see the isosceles triangle right here? If the two sides are the same, if this is 45, E is 45. So I'm going to go down here, and I'm going to write right here, 44 degrees. And my reason that I can say that is ITT. Is everybody okay with the first one? Now, what I usually do when I got a bigger problem like this, I usually then write out 44. I'll put it as a different color. I usually write it out and I put it into my diagram so I can now use this to help find other angles. This is now 44 right here. By doing that, you have now unlocked 2 other angles that you can find. There are 2 other angles that you can now find. What is one of the 2 angles we can now find? Doc, what do you think? B? We can definitely find B. How would you find B?
Add 44 and 44.
Yep. So here's what I'm going to do over here. So we're going to go to B, and I'm going to take 180, and I'm going to subtract 44, and I'm going to subtract 44 again. That's my reasoning because of, what's the acronym? What's the short form of the theorem? Take a look on the front or on your other page. What theorem is this?
ITT.
It's not ITT. We used ITT for E. This one is?
AST.
ASTT, the three angles all add up to this to 180 degrees. Does that make sense? So when we actually do this, this is 88, we take 88 away, are we getting 94? Anybody want to check that in their calculator? $94, is that right? 92. Want to make sure you're paying attention. 92 degrees, there it is. So I'm going to take this, and I'm going to go clone, and I'm going to write it in my diagram.
Sir,
Yes.
attendance, please.
Sorry, yes, everybody is here. I'll submit it in about 2 minutes.
Okay, thank you.
Everybody good? That's a good part to have in the video. Everybody okay with that one? All right, let's go to our next one. What can we now unlock? What letter can we now get? Which one? YD. See the straight line right here? If I just kind of hone in on this right here and this only, right there. Do you see you've got that straight line right here? I know that this side's 44, so what's the other side? We subtract it from 180. So right here, let's clone this. We'll go down to D. D is just 180, take away 44. And what's the reason? SAT. So when we take that away, 180 take away 44, and again, SAT, just on the other page, you can see it on your other page there, it's just 180 degrees. What do we get, 136? Anybody get that?
Yes.
So let's go 136 for this one. And I'm going to write that right here, clone, and I'm going to put it in my diagram so I know this is 136. Now, we're down to 2. Any idea how we could get this one? What are you thinking, Liam?
You can just use ITT and then divide by 2 for the triangle.
Great job, Liam. Take a look at this triangle. Do you see this triangle right here? Again, I like using this smartboard tool. Do you see this triangle right here? What type of a triangle is this? It is obtuse, but what else do we know? Liam just said it was a isosceles. Do you see that? These two angles are the same. A and C are the exact same because of that isosceles triangle. How many degrees do we have to play with here? Well, it's 180, take away 136. But once we take that away, what do we have to do because they're the same? Divide by 2. So here's your calculation. For both of these, we're going to take 180 and we're going to subtract 136. And once we get that, we take away the 136, we have to divide by, and I'll show division by this, divide by 2. Okay, I'll show division that way. And this is 2 things. We can say this because of ITT and ASTT. ITT because it's an isosceles triangle, and the ASTT because we know there's 180 degrees. Do you see how there's 2 little theorems we use on this one? So when we take that away, we get 44, and we divide it in half. Are you guys good with 22? 22 for this one? Is that good? So A is now 22, and you can do a whole bunch of things. You can just say now that I did that work for this one, I can say that this is 22 because of ITT. Because if I know this is 22, right here, if that's 22, then I know this has to be 22 because of isosceles triangle. And do you see all the work that I showed here with the theorems? Everyone has a theorem of what I used to get the actual measurement. What you just did is you just solved this diagram for all the unknowns. Isn't that kind of cool? Is that good with everyone? So here's what you're going to do after you get done your tests and everything else. There is one page for you to do. Right here, you're going to classify each of these triangles. What type of triangles are they? And find each unknown angle. So if you want, you can just write in a small angle right here. So we can call this one A if you want. Right here. That's angle A we have to find. We can go, this is going to be angle B right here. And then we have angle C. And we can say angle D. You can even write that in on your page right now. It's the next page, okay? Angle D. So find each of those angles, describe, okay, what type of triangle. Then, what I want you to do here for each of these 6 diagrams, I don't want you just to have chicken scratch everywhere. I want you to do something like this, where you say each one is equal to. So just as an example, just as an example so you understand. If this was me, the first thing that I would do is I would look at this diagram and I would say, hey, y and 105 are opposite angles. So my first step, I'm not going to do all of them, but right here I would say y is equal to 105, and I'll put the degree symbol. One sec here. And then after that, I would put opposite angle theorem, OAT. And then I would move down and I would say, okay, now what angle can I find, X or Z? But that's how I want you to show it, okay? Any problems with that? So this is your one page. You see on the whiteboard there, your 7.2? That's the one page that you are going to do. Thank you for being so good. I'm going to stop this video. Save that.